The fabric of science should be considered in the same way as that of nature. Everything in it is infinite, but everything in it is necessary. Georges Cuvier, 1769 to 1832. Portrait. In soil where salt water comes to the surface, plants disappear because they can't adapt themselves, with the exception of very special plants like the small saltwort, which manages to adapt itself where all others have disappeared. And in this industrial area, Lorraine, a traditional salt region for a long time now, totally strange areas can be seen where the vegetation has changed completely in aspect and where only some species that are found on the coast can, oddly enough, survive, because they have managed to adapt themselves to the salt. Marary Pelt. My name is Marary Pelt. I'm of country stock. My family were gardeners. I studied pharmacy first, then science, and at the same time a good deal of botany. I was, in turn, assistant lecturer, professor. I pursued parallel scientific and socio-political careers, if it's possible to say that, which landed me at the Metz Town Hall as deputy mayor. Plant biology. The choice of biological indicators offers the immense advantage of allowing a very rapid determination and immediate observations over very wide areas. Plant biology taught me a lot about biology, pure and simple. The more I thought about it while studying flowers, the more I became aware that the principal laws which govern them are the same that govern us. So, one finds a kind of deep sympathy and a sense of belonging. These feelings are now feelings of great tenderness and of delicacy in a world which is very harsh. Plant and man. Development of plant sexuality was the first of a series of works for which I was responsible that I christened Plant and Man. And well, we've seen plants make remarkable discoveries. We've seen them leave the water and adapt to life on Earth. Then we've seen them create wood, which has allowed them to become larger and become trees. And we've seen them make seeds, which have enabled them to wait sometimes years for the right conditions for germinating. So we have a series of stages which makes up one gigantic epic. Pollution. I often say we've reached an age of autotoxicity, and there's no doubt that the time has come to sound the alarm. Ecology. So, with some friends, I founded a European Institute of Ecology at Metz in Lorraine. Our aim in creating this institute was to develop all research and teaching activities and also practical intervention in the field with a view to improving the quality of life and protecting the environment. We've brought in biologists and specialists in human sciences because it's the only way of achieving a comprehensive vision, and here we wanted to demonstrate that in 700-year-old quarters we could create a science for the future. When you look at a tree trunk, The further you get from the centers of pollution, the more lichens you see reappearing, and not just any. You can practically see the level of sulfur dioxide in the air, and you can actually draw a map of air pollution. Though science is neutral, man himself is not. He is committed by the discoveries he makes and their consequences. So for me, the scientist's duty is the most objective and stringent research possible on the one hand, and reflection on that research on the other. In the news. Infrared rays, ultra-high frequency beams, interference and so on pose a visualization problem. The Center for Nuclear Studies at Fontenay-aux-Roses has perfected a device that achieves it. It's a liquid crystal camera. The sensitive part of this device comprises a 25 square centimeter screen with a low thermic capacity covered with cholesteric crystals. The sensitive surface is lit continuously for visual observation, or by flash for photography. A flow of water keeps the temperature of the screen constant. This camera allows the mode of oscillation of infrared lasers, for example, to be studied. With the beam aligned, a series of photographs can be taken by two simultaneously adjustable cameras. Direct observation is equally feasible. Other areas of use: ultra-high frequency beams, interference, holography, the heating of electronic pieces or components. Technology. Geothermic energy. The Earth contains heat. In the sedimentary basins, the temperature increase in relation to depth is an average 3 degrees centigrade per 100 meters. In some areas bound to the major faults on the Earth's crust, there are heightened geothermic gradients, the use of which can be very advantageous. Type of deposit: steam. An example in Guadeloupe in the so-called bouillante. Rainwater seeps into and circulates in the soil to reach the warm zone. As in a huge water heater, thermic convection currents are created. Being completely covered with porous rock, none of the convection heat can escape, and so the temperature rises along with the pressure. Hot springs, fumaroles and geysers can sometimes be seen on the surface, escaping through natural fissures. If a well is sunk to the rock reservoir, steam can be produced. In ideal cases, this steam can be used directly to turn turbines. Type of deposit? Liquids. The most frequent deposits are low-temperature geothermics. Such is the case in sedimentary basins like Alsace, Aquitaine, Bresse, and the Parisian Basin. Here, the geological layer acts like a sponge 7,000 kilometers square, in which is stocked, according to the studies of the BRGM, a reservoir of millions and millions of calories, which has kept 30 million people warm for thousands of years. It's located between 1,500 and 2,000 meters down and has a temperature of 65 to 85 degrees centigrade. It can be used for urban heating in new towns, as at Melun. An installation has been set up by the Société Technique de Géothermie, which heats 2,000 buildings. Principle. The water has a high mineral salt content and so is very corrosive and can't be fed directly into domestic radiators. It has to be passed through heat exchangers. Water in the stratum is restocked by the seepage of rainwater, which occurs on the periphery of the Paris Basin where the porous layers are level. But this restocking is too slow to compensate for artificial tapping. So, a method of re-injection doublets has to be used. On the right, a well for hot water extraction. A pressure of 7 kilograms provides 100 cubic meters of water an hour at 72 degrees centigrade. On the left, a well for re-injecting cold water. A pressure of 14 kilograms. That's what prevents a too rapid lowering of pressure in the deposit. The Earth's heat represents one of the biggest sources of energy for the future. Medicine. The hand. Man is intelligent because he has a hand. This sally of Anaxagoric wisdom underlines the value of that wonderfully complex instrument, the hand. As an executive organ, its prime function is gripping. Its representation occupies a significant part of the cerebral structure. As a sense organ, it transmits all information, including what is needed for gripping. And this information returns to the effector to allow it its regulation and control. Only the extreme complexity of the muscular formations, which guarantee the system's function, allow a really functional programming of voluntary acts. That's why the surgeon has to preserve the hand's sensitivity, for without it, the motor function is nothing. Specific surgery. Each year in Europe, about 1 million people suffer hand injuries, and the hand is injured in 1/3 of working accidents. Badly reduced fractures, mutilations, serious burns. For a long time, surgery has intervened in traumatic afflictions. Osteosynthesis and grafts have proved their effectiveness. For 10 years, scientific progress has allowed practitioners like Professor Raoul Tubiana in Paris to operate on pathological cases: congenital malformations, paralysis, neurological lesions, rheumatic hands, from the most common, rheumatoid arthritis, to the most rare, lupus. Operated on a fortnight ago, this badly burned hand is on the road to recovering a function that the other still exercises. With such stiffness in hyperextension, there is only one solution: to make implants. Rheumatic surgery. This hand, its articulations destroyed, can only regain its function through arthroplasty of the interphalangeal joints. The operation consists of placing the implants between the first and second phalange.
Il faut garder quelque chose, le maximum de solidité côté externe.
It's essential to save as much of the extensor system as possible.
Je vais passer ici. Entre les obliques et l'articulaire. C'est ça, oui.
Severing the head of the first phalange. Preparation of the conical openings which will receive the implants.
La phalange, maintenant, la base de la phalange.
Adjustment on a model. The silicon prosthesis is inert and resistant.
Vous voulez allonger l'articulation. Oui, comme ceci, s'il vous plaît. Merci bien.
Five days after the operation. The plaster was taken off this hand today. Re-education begins, and in a month the fingers will have regained a 70-degree flexion.
Étendez. Vous étendez. Pliez. Encore et encore et encore et encore et encore.
This surgery, still developing, is being called on to render considerable service, given the frequency of injuries to the hand, an indispensable organ for man. Science. They aren't found in the waters of our regions. They come from South America or Africa. But in the CNRS laboratories at Gif-sur-Yvette, researchers in sensory neurophysiology are studying these far-traveled fish. Different aspects: morphology, electrophysiology, analysis of phenomena. An environment as realistic as possible is recreated so that the behavior of these fish in their natural surroundings can be determined. Electric fish. These fish are real electric cells. Certain species produce a strong discharge, up to 600 volts, with a potential of up to 6 kilowatts. Whether in fresh water or in their marine environment, these electric fish use their discharge as a means of attack or defense. When hunting, they paralyze their prey before swallowing it. Others, like the electrophorus, the South American electric eel, have two discharges. One strong, which is used as a weapon, the one weak, which is given off continuously. Weak discharge fish. There are also electric fish which only have a weak discharge. The gymnarch has a regular emission. The mormarus, an irregular emission. This weak discharge, about 1 volt, can be made audible and visible on an oscilloscope. This discharge creates an electrical field round the fish, which enables it to recognize the nature of objects in its surroundings. The fish will go through the plastic ring. On the other hand, it refuses to go through an identical metal-rimmed ring. Group experiments produced a similar result. In difference to plastic, avoiding metal, the fish is capable of distinguishing between objects of different conductivity. Environmental analysis by autostimulation. Its electrosensory system, which makes it sensitive to any modification in its electrical field, enables it to localize an object. The fish possesses specialized organs, electroreceptors. The emission of the discharge creates a field which stimulates the cutaneous receptors. It is, in fact, autostimulation. When an object disturbs the electrical field, the receptors, aware of the modification, inform the brain. Social communication. But these fish are not only sensitive to their own field. They are equally sensitive to those created by their congenerics. If an electrical charge is produced artificially, the fish interrupts its own discharge, then renews it. This is a fish auto-stimulating. But the discharge emitted by another fish is also intercepted by the receptors, which inform the brain. This one stops the process of autostimulation to listen to the emission of the congeneric, then replies. So, a kind of communication is established between the two fish, each expressing itself in a different way while listening to its partner. The study of the functioning of these sensory mechanisms helps towards the understanding of the most complex physiological phenomena.